the processor. There's an SPI SSP interface to PCAP and BP. I'm going just to talk about what PCAP and BP are. There's a 320 by 240, sorry, not by 200, 240 LCD display. It's directly attached to touchscreen and buttons and also to the 1.3 megapixel camera. The baseband processor contains an ARM7 TDMI for the GSM stack and a 56620, if I'm not mistaken, DSP for the digital baseband. It has also a JTAG port, but obviously such chips are not publicly documented, so there's no BSDL file. It's connected to this application processor via USB. Again, has SPI SSP to the two other major chips. It connects via using a UART to the AGPS module. And it connects the GSM SIM module, has 8 megabytes of external flash and 2 megabytes of external RAM. Apart from that, we have the AGPS processor, which is again an ARM7-based CPU that has again 2 megabytes of flash and RAM. And it's again attached to using a UART of the baseband processor. So that's just for the GPS processing. There's a PCAP2 chip, which is for power management, clock, and audio peripheral. It produces 16 different voltages for the phone. There's a very interesting diagram I'm going to show later on how all these different voltages and so on. So that's already quite complex, especially if you talk about power management. It handles all the mono and stereo audio, stereo for MP3 playback and so on, mono for ringtones and the like. It handles clock generation and as well backlight control. So there's two different backlights in the phone. No, actually at least two different backlights. One for the LCD display. The other backlight is the backlight of the buttons in the flip, so which have independent pulse width modulation, so you can independently control and so on. Anyway. So the RF part, well, there's not really all too much information known yet. Just the individual chips and their purpose. So let's look at the software. So the kernel has a number of Monta Vista additions. It has dynamic power management, DPM. I'm not sure whether you've heard about the DPM patches, but that didn't really sound good. Whatever it was. I don't know what it was. My two phones are still here. Anyway. There's low-level drivers for the SPI SSP interface. There is a PCAP audio driver, which is basically OSS drivers for the audio, for the mixers, and so on. There's def vibrator, very important, which you can use using ioctals. You can actually control the PWM of the vibrator, and there's a number of ioctals for doing so. The USB host port is attached to the baseband processor, which is in USB device mode. The USB device port is attached to the port that is the public USB port, which you use for recharging, for connecting to computer. There's a transflash driver, obviously, and there are 3 different proprietary flash file systems. I'm not really sure why you need 3 of them in a single device, but well, that's probably, I don't know. You need 4 CPUs and 3 proprietary flash file systems on a phone these days, I guess. Anyway, all the low-level drivers are in the source code that Motorola has released. So there's no technical necessity of rewriting or re-engineering drivers. But if you look at the code, then there is a moral necessity. So the proprietary pieces in the kernel are mainly MaxCli, GPRSV, and IPsec.o. IPsec.o, well, yes, this phone actually ships, when you buy it as an end user, it ships with an IPsec stack. So you buy the phone, you have an IPsec client, you can make your IPsec tunnels and so on. It's quite convenient. But anyway, that IPsec stack is a proprietary IPsec stack. I mean, we already have 2 GPL licensed IPsec stacks for 2.4 kernels, but now we need a 3rd proprietary one because we cannot use an existing GPL licensed one. I don't know why. Anyway, but at least there's no reason for re-engineering that IPsec module because we can just use the free one. It's a little bit harder for the MaxCli and the GPRSV modules. MaxCli hooks into special callback functions that they have introduced in the USB host driver, and it actually does a GSM TS07.10 demultiplex. So people who know about Bluetooth will have heard about that. It's basically a multiplex of multiple channels onto one serial channel. So you have a number of channels that go multiplexed through one channel. Nothing magic, but just some strange GSM protocol. So what they have is this USB line between AP and BP, over which they talk this TS07.10. And that MUX-CLI driver provides one TTY device for each of the multiplex channels that go over that TS07.10 channel. Then the GPRS works in a way that there's a GPRS v.o module which implements a GPRS line discipline that binds on top of those TTY devices, or at least two of them, because you have two different GPRS connections. You can have two different GPRS connections at the same time using that phone. So it implements this line discipline, which also then it hooks somehow into NetFilter to intercept DNS packets. I haven't really figured out why that is or what the particular purpose is, but it intercepts DNS packets and does something magic. And then it provides GPRS 0 and GPRS 1 network devices. So it's a regular network device. So if you have shell access, you can just ifconfig and do the usual kind of thing. I'm in the process of rewriting these modules to have a free implementation of them. It's actually quite convenient to do so because Motorola has left almost all the development and debugging information in there. I'm not only talking about debugging information of object files, but I'm talking about callback functions in which you can hook in order to obtain hex dumps of all the packets going back and forth on the USB and stuff like that. So it's, I don't know, maybe they didn't have time to remove it. I don't know what the reason was, but it's nice though. So what other software do we have? Well, this actually doesn't run UClipC, it doesn't run BusyBox. It has the full glibc, it has a full bash, it has the full file utils, it has the full, all the GNU system. I mean, why? I don't know. I don't know. It's an embedded device. The GPS is not NMEA compatible. There's no serial device emulation. There's some proprietary library that uses the MUX-CLI kernel module to tunnel through the USB, through the baseband processor to the AGPS module that attaches to the BP. So that's not very easy. The user interface is an embedded Qt and the Motorola EasyX toolkit, and obviously all the front-end applications are proprietary. Java, well, it has J2ME, including 3D Java APIs for strange games. But, well, who wants Java if there's running Linux on the phone? So other applications they have is Opera, Helix Player. So the player can play MP3, WMA, MP4, AAC, whatever. It's a full-based Helix Player. That's the Copilot GPS navigation, map and route program, and so on. Yeah, well. If you play with phones. So firmware images is another interesting issue because, I mean, when you want to flash something of your own onto the device, then you somehow need to flash it. I mean, obviously you could use the JTAG port, or the alternative way is use the official flash update procedure that was designed by the vendor Motorola in this case. What they ship is SHX firmware images to their service centers. I don't think there's any legal way of getting these firmware images, and they're proprietary Windows apps, which actually require dongles, if I'm not mistaken, at least on originally, in order to program them. So the SHX files contain lots and lots of stuff, including a bootloader for the application processor, Linux kernel root file system, language pack, boot-up logo, DSP code, cryptographic signatures, and so on. Anyway, we have managed to build firmware update images that you can use using the official Motorola tool and which do not contain official Motorola software, but still nobody is able to legally get the original or the official Motorola flashing tool, so we need to work on that. Interestingly, the bootloader is also based on a GPL licensed bootloader, so at some point we will certainly see the source code for this bootloader because it's based on the GPL licensed blob. So what does it do? Well, it does GPIO and so on, low-level initialization. Then it opens, then it opens a vendor-specific USB device that you can transfer executable code over USB to the device, and then it jumps into that executable code. And then this executable code will reconfigure the USB interface to create a new USB device with its own endpoints, which then transfers the firmware image into RAM of the phone and then starts reflashing the phone. And then it goes even further than that, because then it needs to transfer some flashing code onto the baseband processor over the internal USB link. Then the baseband processor executes that code, creates special USB endpoints on this second internal USB interface, where it then you send a baseband processor firmware image from the host to the application processor to the baseband processor, where it then is flashed actually onto the device. And you can go one iteration further if you want to update the firmware of the GPS, because that's behind the baseband processor. So it's like this bootstrapping. So there is a reason why flashing only works if the battery is fully charged. Interestingly, since the bootloader is based on the GPL licensed blob, there is support for a serial console in the binary, but it's not used. If you look at it, I mean, you can even officially look at it because it's GPL licensed, so you can actually disassemble it without having any legal problems. So the functions are never jumped to. So there's all the different commands, the strings for the commands, all the code from the commands, all is there in the object code, but those functions, it's dead code and never used. But that's very unfortunate. So I actually now have a modified phone. I didn't bring it because it's very fragile. So I connected all the test pads, JTAG, and the new serial console. So I have abused the Bluetooth UART to create a serial console during boot up, and I used very thin wires and pull all those wires out of the phone and close the phone again in order to make battery and all the PCBs connect again. So I now have a serial console there, which I can use from Linux, from my own kernel, but which I cannot use from the bootloader, even though the bootloader has support. But anyway, if you see the source code, all that is the past. So, well, yes, they have a USB device port, but actually what it is an enhanced mini USB, MU port. So depending on on the values of resistors that you put either from one of the two USB signaling wires to each other, or to the plus USB voltage, or to ground, then you can switch that USB port into multiple different devices. So it can either be a USB device port, or a serial port, or a stereo analog audio signal, or a 500 milliamp charger, or a 100 milliamp charger, or a car kit, either easy install or professionally installed, or a factory test mode. So either if you use 3.3K or 10K or whatever kind of resistance value, there's a special logic inside the phone which then reconfigures and switches all the lines. It's quite amazing how much you can overload a USB port. But yeah, analog stereo audio on USB is certainly something I've never heard before. So the question is, how do we use all these configurations? Because officially it only runs as a modem emulation or mass storage device. But there's some number of undocumented configs. So once you have shell access on the phone, you can use the proc file system to switch it into different USB modes. So you can switch it from whatever mode into, for example, USB network. So it actually provides a network device over USB, and you can telnet into the phone. The phone even runs a Samba server. Yeah, guess people were using Windows to develop software for it. But it also has NFS modules, so at least. There's a PST mode, which is the mode used by the phone support tool Windows application. There's a mode that is called DSP log, which sounds very exciting, but I haven't really found out anything about it. But well, apparently it is some way to dump data from the DSP onto the host system. There's a net monitor mode, which also sounds very exciting, but I haven't looked into those ones either. So what's the status? We have a very good picture about the phone architecture. We have an initial 2614 port done, which has still lots of bugs. We have an updated toolchain. So originally the toolchain used was a GCC 3.2. Now we have a 3.4 toolchain. People have worked on an EasyX OP embedded Qt integration. So you can coexist native Motorola EasyX applications with OP from Open Embedded. We have replaced the proprietary user space Bluetooth stack that they're using with the native BlueZ. I've obviously done NetFilter IP tables modules for the kernel. So even with the stock kernel, you can now run packet filter and network address translation on the phone, which obviously is required if you're a NetFilter developer. Then this is one of the basic things you need to do. So I can now run a network between the phone and my computer, and can NAT between the USB network and the GPRS connection and stuff like that. Anyway. Well, there's stuff for AF packet modules, so you can run Nmap and TCP dump. I've cross-compiled LSOF, BusyBox, Bash2, Game Boy emulator. There's also a console Qt application you can use on the phone itself, on the touch screen, in order to access the shell without an external device. There's a number of to-dos. Well, first of all, get